Okay, today I'm joined by David Cheshire, who's Sustainability Director at AECOM, the Fortune 500 infrastructure consulting firm. Thanks for joining us today, David.
Thank you. Thanks for inviting me. It's brilliant to be here.
David has a new book out with a very intriguing title, Regenerative by Design, Creating Net Positive Buildings and Cities. And we'll dig into that in a second. But first, perhaps, David, you could give us some background, tell us how you got started in sustainability, particularly if there was one moment where you really went all in.
Yeah, no, there definitely was. I mean, I have a very distinct memory at school. I got a poster. This is back in 1986, in those halcyon days, that was comparing the world's age. Saying it's 4.6 billion years old, but let's scale that back to 46 years because it's a lot more, understandable as a timescale. And then it says, well, if you scale all that back, then humans have only been here for 4 hours. And the Industrial Revolution started 1 minute ago. And that for me was just really, and I just thought of the sort of what we've done in that minute to the planet, just really, really converted me, I think. So from that, I suppose I've always been an environmentalist, I guess. And in my first degree, I did a dissertation in low energy buildings. And then I did a master's at Cranfield University on energy in the built environment. Because back then there wasn't really anything about sustainability, wasn't a thing. It was all about energy, and then it became environmental. And then I spent the last 30 years really in my career looking at sustainability in buildings.
Yeah, and I'm very familiar with that. When I did my degree, there was no such thing as a sustainability degree. But how have you felt that importance has developed over your career?
Oh, hugely. I mean, I was, at university when BREEAM, which is an environmental assessment method for building, first came out, and that was really the first chance that we got as professionals to get into the room. There just wasn't any mention of it, but back then it was in the hierarchy, it was right at the bottom. You had the architects, the design team meetings, we'd have the architects and the engineers talking for ages about what they're doing. And then there'll be all the way through to health and safety. And then if you're lucky, you've got BREEAM and sustainability or environmental stuff right at the very end. Yeah. Quite often it got shifted over to the next day because they hadn't got time to deal with it in the agenda. But now it seems to be, to me anyway, right at the very top. It's the first thing that we talk about at the project meetings and design team meetings that I go to. It's been a huge shift.
Yep. So coming up to the present day, you said it's right at the top of the agenda. Where, what business drivers is AECOM feeling, to put it right up there?
I mean, I'm working in London. A lot of my work is in London. And I think there's a very, very strong policy shift and drive in here now, as there is in lots of the UK. So I think obviously there's the net zero agenda that happened, what was it, 3.5 years ago, where all the big corporates committed to net zero, and that's driven developers very quickly to say, hang on a minute, we need to be making sure all the buildings that we deliver are meeting this if we're going to be able to rent them or sell them. So that's really driven it, I think. And then things like the circular economy have gone right up the agenda in London because of the London Plan policies. So the drive to reuse existing buildings and retain and refurbish and as opposed to demolishing everything and building new. And we're seeing a sort of market occurring for reusing components and parts of buildings and stuff. So that's been a big shift for us and for me, because I've previously written about a couple of books about the circular economy as well, and before that became a thing. So that's been very exciting. And I think now really there's just a starting of a shift towards this idea of regenerative design, which is really what I've just been writing about currently.
Yeah. Just before we get into the new book, you mentioned your book on circular economy. It always struck me that in the in the building sector, those resources are locked up in a building for decades. So that seems to be a particular challenge. It's not like single-use packaging being recycled constantly. So is there a real challenge there in that obviously the demand for materials will change between building X being built and its replacement coming along, whether...
Yeah, no, yeah, absolutely. That's a great question. I mean, well, there's two parts to that. I think, firstly, in lots of our cities, there is a much faster churn in the last 50 years or so, where buildings are being knocked down within 20, 30 years of them being constructed, and I've got lots of examples of that, and which is really quite frightening, because we almost have turned buildings into a disposable commodity. That's the risk. But then also we're fitting out buildings at an increasingly faster pace. So, or refitting them, sorry, I should say. So, retail units, offices, even, homes are being stripped out and refitted at a phenomenal rate. So there's a massive amounts of resources coming out of that, which is a bit of a blind spot in many ways, that people don't really think about those, refits and refurbishments going on compared to the big new building that's gone up. But the amount of raw materials required for that and the amount of waste it's generating is huge, and often less well regulated, because it's a smaller scale, not regulated, but managed and looked after and thought about in terms of a reclamation and reuse. So I think, although you're right, there's concrete frames and steel sections that are locked into buildings for a long period of time. Hopefully, the idea of that, and again with the circular economy, is that you apply different models to different elements of the building. So, for the structural elements, you're going for the long life, loose fit approach, and trying to make our buildings more adaptable, and looking at buildings that have stayed the course. If you look at Victorian warehouses and Georgian townhouses, they're still around today and had multiple uses, because they were not necessarily deliberately, but they were designed in a way that has proved to be very adaptable, with good, nice, clear floor plates, rectilinear shapes, very good use of daylight against stopping cooling issues with overheating and things, by not having high levels of glazing and everything. And those are the sorts of things we need to be imitating, so we keep the buildings that we've got in use for so much longer. And then, rather than having to say, oh, we're going to wait for a steel girder to come out of a building, well, we keep it in the building it is, and we'll keep our building stock in use for longer.
Right, fantastic. So, coming on to your new book, how would you define regenerative design?
Yeah, I think in a sentence, it's creating buildings that are an active part of the ecosystem. That's the sort of crux of it. So it's moving away from this idea that that sustainability has been sort of reduced. I mean, sustainability was a brilliant concept in that is looking at meeting the needs of future generations without whilst maintaining the needs of current generations. That as a concept, that's amazing. But if you look at what's happened in the built environment over the years, that's been distilled down to a checklist of things that you need to do to be a little bit less bad. So it's sort of got distilled down to that, rather than that grandiose concept, which is an amazing concept. And I think by being a bit less bad, and by that I mean using a bit less water, a bit less energy, generating a bit less waste, and a bit less pollution. But it's not looking at really how can we make buildings better for the planet. And I think the climate and biodiversity crisis has shown that 30 years of effort I've put in hasn't been enough. We've got to do so much more. And the built environment has this massive impact. Although in the footprint area, it's very efficient. We don't use that much land for our cities, and we accommodate a lot of people. The shadow that it casts is huge. If you look at all the mining that we have to do to get all those raw materials from around the world, and increasingly more difficult environments to get that out of, and damaging more pristine environments and habitats to do that, it's really quite shocking. And then you look at all the things we take for granted, the electricity use, the electricity we get that we just connect into. We don't really think about where's that come from, and what impact is that having on the biodiversity world and everything else. The water is the same, both with the supply of it and the treatment and capture of it, and distribution, but also as we're seeing in the UK now, the problem with treating all the wastewater that comes out of our buildings, which we just chuck away down the drains and don't think about, along having mixed up potable water, mixed it all up with feces and urine and bleach and goodness knows what, and shoved half of it in our rivers, it seems, at the moment. So and then there's food and there's all these other things that just come into our cities, and all the waste that just leaves them, and the impact that's having on the planet is well, it's unsustainable, I suppose, is the best way to put it. So I think what we're thinking about here is this vision of changing what we're looking at towards one where buildings are giving back to the planet. So we're not just being less bad. There's a sort of nice graph that goes from the sort of down the negative side of less bad. It goes through a sort of the 0-0 of the axis, and then up to the positive, and says, what if we can create systems that restore and regenerate the ecosystem? And they metabolize like living organisms effectively. So, the vision is you can have buildings that contribute energy and food. And, we've got examples of doing this. They capture all that water and they use it in the building rather than treating it as a waste thing that has to be rainwater that has to be flushed away and got rid of out of our built environment. We can sequester carbon in our buildings rather than them being an emitter of carbon. They can clean the air, treat pollutants, even reclaim nutrients from the waste. We can use local resources, and we talked about circular economy earlier, but part of that certainly fits in with a regenerative idea that you could be keeping those existing buildings, but also using locally available resources and materials. And then our local infrastructure could be defending against flooding, could be a haven for pollinators, could be reducing overheating, and of course reconnecting us as humans with nature and reminding us that we are an inherent part of the ecosystem.
So what's the scale in terms of carbon? Say, let's because it's everybody's hot topic. Excuse the pun, but what is the scale for net positive? In a building, how much more than the footprint of a traditional building can a regenerative building extract from the atmosphere?
So if you're talking about energy use, I think there's a couple of examples of projects that, well, there's quite a lot of examples, but the ones that are probably the most interesting are ones where in a city centre development, buildings have managed to generate more energy than they use. So it depends. If we're talking about residential, it's a lot easier. If you've got a relatively low-rise building, you can generate enough energy to cover all the energy use in that building, because it's not high use in a typical residential building. If you're talking about a commercial building, like I'm sitting in now, then that's going to use around about 150 kilowatt hours per meter squared per year as a rough idea. If you say a roof filled with PV, for every meter squared area of that roof, you can generate about 100 kilowatt hours per year. So if you can generate that, so that means if you've got a single story building, an office, and you cover it completely with photovoltaics, then you could probably get your energy use down enough that you could meet all of that need. With some to and fro from the grid. Over a year, this is so on net. So the problem then comes if you put 2 stories in, you're only going to meet half of that demand, and it goes up as you go up to a taller and taller building. So if you're sitting in a 15, 16 story building, you're only going to get a fraction of it from photovoltaics. But for example, the Bullitt Center in Seattle, there's the PAE Living Building in Portland, and the Santa Monica City Hall East are all have certified under the Living Building Challenge, which we can talk about in a second. But that is, all of those buildings are generating more energy than they need, and they're city developments. They're not very tall; they're only 6-7 stories high. They cover the roof in PV, and what they're doing as well is they're also using the neighbouring areas or buildings to supplement that. So they might be covering the bike sheds or a neighbouring school they've covered in photovoltaics as well and funded that. And then you can get to a point where you generate more than you need.
Right. So it's sort of, it sounds like it's more just tipping the scale in the positives rather than, this building isn't going to be a sort of center of sustainability in terms of compensating for all the.
No, absolutely. Yeah, you're right. So you're not going to be able to generate enough for for neighbouring developments if you're doing. But I think there's a lot of good things about trying to generate as much as we can within our towns and cities, because there's this big, understandable discussions and disputes now about land use, about should we be covering our agricultural land in photovoltaic cells, which you can see a lot going on in the UK now. But you think people are saying, well, hang on a minute, shouldn't we be using that for our food instead? So again, this is well, we've already got lots of roof area in our cities and towns that isn't being used to generate energy. You look at all of our stations and all these other buildings that you think, crumbs, we could be covering all this with photovoltaics, and then they could become net positive providers. And then, sorry, and the other thing we need to do, of course, is it's not enough just to cover our roofs in PVs. We also need to radically cut the energy demand. And I think what's interesting about the regenerative idea is that one of the key cornerstones of that is you say, what resources are available on the site? So how much energy is coming from the sun that's falling on the site? How much rainfall is falling on that site that we can use and capture? What materials are available already that we could be using? What biodiversity is there? So anything locally that we can use. And then what you do is you set your budgets your design budgets and limits according to what's available. And it completely changes that mindset, because you say, well, I've only got this much energy and this much water. Let's redesign the building to a state that we can do it. And that's certainly what some of the case studies I've got in my book are showing, is that once you start thinking like that, you think, okay, well, we'll make sure that we've designed it to be 50 kilowatt meter squared per year energy use, so that we can meet it all through that.
So you mentioned some examples of buildings which had my mind's lost that standard that you just mentioned, the living
building challenge. Yeah.
Living building challenge. To the user, if you were, say, working in an office that was designed to these principles, or living in a domestic dwelling that subscribed to these facilities, would your life be much different from a traditional building? Or would it feel different? What would the tangible difference be?
And that's a really nice question. Yeah, I think it's certainly very. I mean, interesting. The living building challenge as an example. I mean, this is an interesting label, because it genuinely is a challenge, and it goes well beyond something like BREEAM and LEED, which are the sort of conventional environmental assessment methods used for buildings. And it includes things like beauty and health and well-being in there. So from an immediately tangible perspective, something like, for example, the PAE living building, the occupants of that building were happy to pay a 10% premium on their rent, because they knew of the productivity benefits that building would give them. So if that's a real tangible, that's probably one, real evidence of it. But you're going to get if you're driving out all the chemicals in the building, the nasty chemicals that we're all breathing in from at the moment in our buildings, then that's an immediate benefit. So you're going to get better air quality, you're going to get good use of daylight, connection with nature. All of those things are all things that actually we love, and a lot of us are sitting in white boxes that are not reminding us in any way that we're just organisms and animals like all the rest of our fellow species.
Yeah. And you mentioned before about existing buildings and Victorian buildings, etc. But are those regenerative design principles applicable in retrofits, or is it better to to start with a blank sheet of paper?
Oh no, they're definitely applicable. So I mean, a lot of the case studies I've used are new buildings, because they're all exciting and glamorous. But you're absolutely right. The retrofit is a huge opportunity. I mean, we talked about circular economy already. Straight away you're onto a winner, because you're using existing resources that are there rather than knocking things down and building new. But putting photovoltaics all over the roof using microbial fuel cells, putting on green and blue roofs, sustainable drainage systems. Some of these buildings are putting in vacuum flush toilets, for example, which use just a couple of teaspoons of water a flush rather than 6 liters or 6 liters. So, yeah, all of these things can be retrofitted, no problem at all.
Right. So we may see more and more of them coming. So
hopefully,
you mentioned, and again at the start when we were talking about the sort of business drivers on AECOM to adopt these sort of principles or to deliver them, but how does the market feel at the minute? Are people ready for this, or is it, nice idea, David, but can you cut 10% off the cost, please?
Yeah. I think at the moment it's an emerging area. I mean, I've tended to sort of accidentally do this in the past, where I've sort of said, I think this is the next thing that's coming, and I was sort of fairly lucky with some of the things I've come up with in the past around some CIBSE documents I've written, Chartered Institute of Building Service Engineers, where things were. I was talking about embodied carbon in 2013 when it wasn't really a thing, and circular economy was. I published that book in 2016, and then in 2017 the GLA published their draft London plan, which included circular economy and my diagram in it. That was pretty cool at that point. So this is my punt, that what's coming next is regenerative design, and it's not based on gut feel. It's based on what I'm seeing, a shift in the market. I'm seeing more events that talk about regenerative design now. The architect world is definitely moving that way, with more people calling themselves regenerative people within the architectural practices. There's the Architects Declare have published a regenerative design primer. I think they have the second edition of that, and they've got a regenerative design index, which I thought was really cool, where they're actually what they're trying to do is they're trying to shift mindset. So they're saying that things like the Sterling Prize are what architects currently chase and what they're rewarded for doing, and they're saying, look, we're going to put out an alternative index that says, look what these practices are doing in terms of regenerative design approaches.
Yeah.
On the basis that they're hoping that will generate a new market and new business, and it already, some very niche areas. It already is, I think. At my launch event for my book, I had one of the major developers in the UK at the top of the agenda. So Matt Webster from British Land was there talking about what they're doing and where they're at, and I've got now lots of other follow-up sessions with other key clients saying, tell us all about this, Dave. So I think there's a shift in the market, definitely.
That's fantastic. And how much does legislation come into it? Because I always hark back years ago. I went to Portland, Oregon, and I don't know, they have this policy where you have to, if you want to build a new development, you have to deal with all stormwater on site, which means that the city centre is just covered in all these wonderful little gardens, because there's no other way of, they can't just concrete over everything, because they have to deal with this and meet this stormwater target. And you were talking about extracting nutrients from waste, and obviously we have the nutrient neutrality regulations new in the UK. So do these policies help you stay well ahead of those legislation, or do you find that developers are only interested in sort of moving up to the legislation and stopping? What's the relationship between the rules and sort of what's quite novel ways of looking at a building?
Yeah, I think this is a really important point, because I think it's difficult because I'm in a bit of a rarefied environment here. I mean, I'm working with some of the big developers who are pushing well beyond legislative requirements, because they want to demonstrate that they're doing things that are well beyond it. In terms of net zero and all this and all these things. We're working with people like Landsec who've set their net zero targets, very challenging targets that they've published, and others, and starting to look at biodiversity indicators as well. As you know, there's already the biodiversity net gain requirements. and people are looking at that. So that's coming in. I think you're absolutely right about nutrient neutrality. Natural England saying that we can't build in the Wye Valley because it's overstretching the sewage works and causing so much damage to the river. And that was I think it's one of the few examples at the moment where there's a genuine recognition of environmental limits coming through, through policymakers to say, hang on a minute, we cannot actually do any more in the Wye Valley because it's just causing too much damage. And this isn't just buildings; it's also lots of other stuff going into the rivers and in terms of agriculture and all the rest. So it's a multiple systems level problem that we need to fix. But it's having an immediate impact on the built environment and developers who want to build in there. And similarly, in Cambridge, the Environment Agency is saying that new developments must not increase their abstraction rates of water because they're worried that they generally don't think there's enough water resource in the region. So, and I think these sorts of things are going to start to hit. So I think we're going to start to see that sort of stuff coming in that says, look, there's a limit to what we can do now. So rather than this duty to connect, which the water authorities have, for example, at the moment, I didn't know this till recently. I didn't realize that they are obliged to connect any new building and provide the water it needs. And if you think of that from an environmental perspective, that's bonkers. There's no recognition there's no recognition that actually we haven't got enough water potentially in that area. No, hard luck. You've got to do it.
Yeah.
So I think that's going to start to hit us. So if we can start to create this built environment where we're doing a lot more of this ourselves, within our towns and cities, and not being so reliant on this massive shadow of infrastructure that we need to provide it, then I can start to see how that might help us carry on building and accommodating all these people that we need to accommodate. And in terms of just on the other side of that, in terms of the nutrient capture idea, I think what I was really impressed by was that the PAE living building, as an example, using that one quite a lot because it's got lots of good stuff in it, is they've actually found a way to extract the nutrients out of the wastewater and even the black water. So they're basically composting on site. And there's phosphates and nitrates in our waste, which of course is a fertilizer. So they're cleaning all that up and then using that and selling it. So they've got the potential to sell it. I think they talked about $50,000 a year worth of nutrients that they can extract out of that one building. And from a systems perspective, and that's what this is all about, looking at the wider systems and the ecosystems, that's incredible because at the moment we're mining phosphates and then we're fixing nitrogen out of the air using resource intensive processes, and then we're using that as fertilizer and spreading on our crops. Yes. So if we could just take, and then of course the wastewater that's coming out of our buildings and our cities is then being tried to be cleared up, but some of it's being dumped in our rivers. So it's all completely wrong. We could be completely changing the system and saying, let's stop mining for all this stuff and fixing nitrogen. Let's just extract what we're creating and use that, and then we get rid of two problems at once.
It's fantastic. That's my sort of solution. Just some practical point. How are they doing it? Is it reed beds or reverse osmosis, or what are they doing to treat this water to take the nutrients out?
So it's a complicated system. So they've got rainwater capture. So that's all cleaned up and that's used for, in one building it's potable and one, so the Santa Monica building, I think they're actually rotating it to potable levels. And I think they are in the PA building as well. And then there's a grey water recycling system, which cleans up the grey water using conventional grey water recycling technology. And that's used, what that does is takes the shower water and the wash hand basin water and cleans it up enough that it can use to flush the toilets and other things. And then there's a black water system, which basically it's basically got some composting bins. But industrial composting bins in the basement or in the ground floor, and then those take all of the solid waste, and that sits there and matures over time, and then it's taken away very infrequently, apparently, only sort of once a year or something. They need to take that away, and then that gets further secondary treatment, so that it can then be completely cleared for agricultural use.
Yeah, and for these sort of more novel technologies, is the supply chain there, or does it need to develop? We often hear that, for example, heat pumps, the supply chain needs to develop. And I must admit, I'm sort of waiting for heat pump 2.0 rather than 1.0 myself. So where the supply chain for some of these approaches?
Yeah, I mean, it's clearly still very niche, and this is one of the big issues is how do we get into this loop where developers are saying, show me all the innovative things we can do now, Dave. And I say, well, there's this, and this. And then the next question they ask is, well, show me where it's been done before. And I go, well, hang on a minute. You wanted something innovative. Someone's actually got to take the leap and go for it.
Yeah.
So I think this is why I wanted to put some case studies in that we're actually forging the way here and saying, look, here's what we're doing. And I think what's been really powerful is there's two tests I was trying to apply to these when I was choosing them. One is it scalable?
Mm-hmm.
And the second thing is how generous are they with lessons learned? Because that sort of answers your question, I think, because I think the first of those is that we've got to be able to scale up these technologies. So if this is a sort of a wooden shack in the woods made of straw bales, and it's single story and it's covered in photovoltaics or whatever, that's very interesting, but not really going to help us build all the 1.5 million homes and all the other things that we need in our cities. So I was choosing buildings that were some of them developer led, some of them public sector, that were actually buildings that we could replicate basically, and those technologies are replicable. Certainly, what was interesting about the Bullet Center, which is the sort of the original Living Building Challenge commercial looking building, which is a 6-story building in Seattle with this massive photovoltaic array that's actually bigger than the area of the building. Sort of it oversails it on the sides. Was that they wrote and are still writing lots of papers and sharing all their information about how the building is currently performing. Mm-hmm. And they wrote a really good paper about their original water system, and particularly the black water treatment. And they said, look, okay, we've learned a lot from this and we've had to change it.
Yeah.
And what the PAE Living Building did is took those lessons and applied them. And one of the examples was that the composting bins were one or two of them were filling up because people, us humans, like to go to the same stalls every time in the toilets because they're nearer. We don't have to walk so far. So those were filling up faster. And then they were having to empty those more than once a year, which they weren't expecting, whereas the others were still empty. And actually what they did in the PA building, and they've now retrofitted in the Bullet Center, is to basically spread the load, if you want to put it that way. So, I think what's really valuable about this is we have to be sharing those lessons. And I think in the buildings industry, as in many industries, we are very keen on saying how great everything has been. Mm-hmm. And didn't we do a good job on this? And also, we don't tend to go back into our buildings. So designers don't tend to go back into their buildings. And often that's because we're not allowed to, because the building has been sold, the building is now leased fully or something. So we can't get back in and find out what happened. So those owner-occupier buildings, those university buildings and all those things are so valuable to us. And the pioneering ones where they try new stuff are the ones where we need to encourage and create a safe space for people to say, okay, I got that wrong. This didn't work, but look, this is what we should have done. And you can learn from that. It's just essential to make the change.
I was just laughing to myself because when I was talking before about user behavior, I wasn't really thinking of choice of toilet cubicle. It seems, but I understand it makes a lot of sense. So I don't know whether they have to. I don't know. Put a red light on one to encourage people to go to the others.
Well, yeah, but no, they've changed the system now so that it actually distributes this automatically, so you don't have to worry. Yes. So you don't have to change that. But I think coming back to your point about changing user behavior, I think it does and will, but I think it does from a different aspect. Is that, for example, I spoke to some researchers who've come up with microbial fuel cells.
Mm-hmm.
And these are incredible bits of kit. So what they do is they take your wastewater, and the microbes basically eat the nutrients and everything in the water. As a byproduct, it creates electricity. Not a huge amount, but it creates electricity. And the researcher said to them, look, he's got now to the point where he has been testing this in various places, but he said, look, you could create a domestic fridge sized unit that you could put in your house, and it would treat all your wastewater. So it would come out clean. And this includes human pathogens, because the microbes actually see the other human pathogens as a threat. So they eat them as well and kill them.
Yeah.
So actually you come out with clean water that's actually safe. I'm not suggesting we drink it, but it can certainly go back into the natural world without any risks. And you're generating energy as a byproduct, which is amazing. And what it made me think about was that in terms of changing behavior, that if you know that your little unit there is sitting there with loads of little microbes in it, chomping away at your wastewater and saving you money in the process, and because hopefully you can then negotiate with the water authorities and say, well, I don't need I'm treating my waste, you don't need to do it, and all the rest, then you probably would think twice about pouring a whole lot of bleach down your sink. Yeah. If you thought that might kill it. And you might think about, putting in your water system that would be able to deal with that better. And similarly if you've only got, certainly people I speak to now who have gone the whole hog on their energy in buildings and put photovoltaics on their homes and put air source heat pumps in and things, they're hyper conscious about the energy they're using, partly because it's saving them a heap of money. I've got a friend up the road from me who's basically just worked out an algorithm and done a deal with his energy supplier to get the cheapest possible energy at all times, and he's using hardly any energy and paying hardly anything. So I think it will and should change behavior, because I think at the moment we're just understandably oblivious to the amount of resources that we consume at every click of our mouse and our keyboard, and every flush of the loo, and every time we order some food from whatever supermarket. So I think it will be a massive change. Yeah,
you mentioned scale in your answer there, and noting that the name of the book, the subtitle is Buildings, Net Positive Buildings and Cities. What are the, I suppose, opportunities and challenges for going from, say, an office development or a small residential development to a chunk of a city, a suburb, or that on a higher scale? Does that create problems, or does it make the solutions easier?
Well, it's absolutely essential. It's part of the whole solution. So one of the problems we have at the moment is, again, totally understandably, is we're thinking about the building and the red line boundary. We don't really think beyond that. So we don't think about the electricity that's coming into it, but also we're not thinking about the locality. Yeah. And what the whole regenerative design approach is to be focused a lot more on place and the setting and the locality, but looking at it from not just, because we're quite good at it from a social perspective and from an architectural setting and that sort of stuff. We do that, but what we don't look at is the ecosystem, and say, at one time this site was a thriving ecosystem. Okay, it's not now, maybe hasn't been for 100 years or whatever, but it was at one time. Can we come back and replicate that ecosystem, the ecosystem services now? Can we do that again? And it's really interesting, because infrastructure projects, and when you get to the scale level, they're already looking at this ecosystem services idea. It's something that hasn't entered the building world, as in the built environment, in my world, until very recently. And the idea of ecosystem services is it's saying that the ecosystem provides all of these things for us. It provides us with food, the air that we breathe. Right now, we're taking a breath, you and I, and without the ecosystem, there would be not enough oxygen in if any, in the atmosphere, and we'd be dead. So that's pretty important, or the most important thing. Forget all these other things. That's the single most important thing, and it's giving us fresh water to drink. It's giving us soil that we grow our food on, the pollinators. It basically gives us everything that we need, and we can replicate quite a lot of what it does. Things like sequestering carbon, things like capturing the energy from the sun, even growing food in our cities. We can replicate that in our built environment. But you're right. I don't think it's not going to work if we just focus on the individual buildings. We're going to have to look at it at the locality, at the regional level, at the city level, and say, right, what can different parts of the building environment can provide these ecosystem services?
Mm-hmm.
And another great example of that is in my colleagues in China in the Shanghai office. There's something called sponge cities over in China, which I'm sure you've heard of, which is this idea that our cities are all impermeable at the moment. We cover everything with concrete and tarmac, and when there's a flood event or a stormwater event, that we can't cope, as we're seeing in around the world in the last few years. So with those low-lying cities on the Yangtze River, they're actually building in green areas into those cities and saying, look, we have to do this. I was having a chat with a colleague yesterday about maybe we should do this in New York, and she was going, "You must be kidding! We can't. How would we do that?" But actually, I think we're going to have to start thinking about how we build in that aurous element into our cities to be able to absorb those huge rainfall events that are occurring and the rising sea levels and everything. So I think it's a change, and it's at all scales, and it's at the national and the global scale as well, because we're looking at how we generate energy. And in the UK now, we're moving this big shift towards the energy transition, which is fantastic. And we've done an amazing job in the UK to reduce the carbon emissions associated with the electricity grid. And we're looking like we're going to go even better in the next few years. But actually, that has a huge impact on the amount of copper that we need, and copper and all the other precious elements that we're going to have to reinforce the grid, and we're going to have to build wind turbines and all that stuff. It's a huge amount of resources to do that. If we can do more of that in our cities, and land use, of course, back to what I said earlier, if we're not using as much land to generate all this, then we're solving problems again at all different scales.
Fantastic. And I appreciate I've used up quite a bit of your time here, but if you could change one thing that would accelerate uptake of regenerative design, what would it be?
Oh, that's just the hardest question. I think, as I said earlier, I think things have already started to change, so that's a really good sign.
Mm-hmm.
But I think, what all the research I've done and everything shows that this is a systems change. And if you go to the sort of leader, I think in systems change, Donella Meadows, she talks about the best way to change a system is to change the mindset that went into, and the paradigm that went into creating that system.
Yeah.
And I think it's incredibly powerful thought, because she's saying, look, it doesn't help if you just tweak a few targets and numbers down this end of the scale, because that's not going to change very much.
Mm-hmm.
But if you can actually get all of us, and we're all part of this system, aren't we? We're all making decisions that keep that system in play. If we can start to think about our connection with nature and natural systems and say, look, hang on, we are an inherent part of the ecosystem. How can we make an active contribution to the ecosystem in everything we do, and try and help to preserve, restore, and enhance it? And then I think we can start. That's the single thing to do, I think.
Fantastic. Well, thank you very much for joining us today, David, and introducing us to the idea of regenerative design. David's book is out now. It's called Regenerative by Design, Creating Net Positive Buildings and Cities. It's published by RIBA, I believe, but it is available on all good bookshops, possibly online ones. So a quick Google you should be able to find it. But thank you for joining us today, David.
Brilliant. Thank you. It's great to talk to you.
Just a quick postscript.
David contacted me again after the interview because he felt he hadn't fully answered my question about getting nutrients out of a building. So he sent through an article about the PAE Living Building in Portland, Oregon. And they take urine from the toilets and extract nitrogen and phosphorus from that liquid to use as fertilizers. So basically, they use steam distillation to get the nitrogen out in the form of ammonia, and then they add magnesium, which precipitates out the phosphorus as a crystal. I'd just like to thank David again for filling in those details, because I do love to know exactly how these methods work.